Imagine a continent slowly tearing apart, its landmass splitting like a giant puzzle piece being pulled from a board. This isn't science fiction, it's happening right now in Africa, and scientists have just discovered the geological heartbeat driving this dramatic transformation. But here's where it gets controversial. This process isn't just reshaping a continent, it's birthing a new ocean, and it's happening faster than we thought possible. Could this be a glimpse into Earth's future, or a reminder of its violent past? Deep beneath the Earth's surface lies the mantle, a layer of hot, semi-solid rock that churns and pulses like a living organism. These pulses, known as mantle upwellings, are the unsung heroes, or villains, depending on your perspective, of our planet's geology. They create volcanoes, fracture continents, and even carve out new ocean basins. But how exactly do they work, and what does this mean for Africa's future? In East Africa, the Afar Depression stands as a geological wonderland. It's one of the few places on Earth where three divergent plate boundaries collide: the main Ethiopian rift, the Red Sea Rift, and the Gulf of Aden Rift. For years, scientists suspected a mantle upwelling was at play here, but its true nature remained a mystery. And this is the part most people miss. It's not just a single stream of hot rock rising from below. It's a complex, asymmetrical patchwork of plumes and materials, each with its own chemical signature. To uncover this hidden world, researchers from the University of Southampton and Swansea University collected lava samples from over 130 young volcanoes across the region. By analyzing the chemistry of these rocks and combining it with existing geological data, they painted the clearest picture yet of the upwelling structure. Led by Emma Watts, the team discovered that the mantle beneath Afar pulses like a heartbeat, with each pulse carrying distinct chemical markers. These pulses are channeled by the rifting plates above, which stretch and thin, allowing the hot material to rise more easily. This weakens the Earth's crust, accelerating the birth of a new ocean basin. Here's the bold part. Co-author Tom Gernon compares this process to a cardiovascular rhythm. The chemical striping suggests the plume is pulsing like a heartbeat, he explains. But it's not just a steady beat. These pulses behave differently, depending on how fast the plates above are pulling apart. In areas like the Red Sea Rift, where the crust is tearing apart quickly, the mantle flow is faster and more focused. In slower regions, the upwelling spreads out gradually. This study reshapes our understanding of how continents break apart. The evolution of deep mantle upwellings is intimately tied to the motion of the plates above, says co-author Derek Keir. This connection influences everything from volcanic eruptions to earthquakes and the very process of continental breakup. The plume beneath Afar is eroding the lithosphere, Earth's rigid outer shell, thinning it to as little as 15 kilometers in some places. Combined with the stretching from plate motion, this thinning triggers periodic volcanic episodes blanketing parts of Ethiopia in lava and marking the birth of new crust. But here's the thought-provoking question. Could these mantle heartbeats explain past volcanic bursts and sudden environmental changes in Earth's history? Scientists believe so. Large igneous provinces, like the one that formed Northern Ireland's Giant's Causeway 60 million years ago, are linked to climatic upheavals and even mass extinctions. Understanding the tempo of the Afar plume could shed light on these events and help us predict future geological shifts. Researchers are now mapping mantle flow beneath thin plates and studying how it directs volcanic activity. Deep mantle upwellings can flow beneath tectonic plates and focus volcanic activity where the plate is thinnest, Keir explains. Future studies aim to uncover how fast this flow occurs and what drives it. Here's the counterpoint that sparks debate. While some see this as a natural, inevitable process, others worry about the potential consequences. Could the birth of a new ocean basin destabilize the region? Or might it offer new opportunities for geological research and resource exploration? We invite you to join the discussion. What do you think? In the end, this study reveals a dynamic connection between the deep Earth and the surface we inhabit. For now, scientists can hear the planet's mantle pulses beneath Ethiopia, a rhythmic signal of forces slowly reshaping our world. As Africa splits apart, the outlines of a future ocean are being sketched, reminding us of the ever-changing nature of our planet. The full study is published in Nature Geoscience, offering a fascinating glimpse into Earth's deep puzzle. What piece of this puzzle intrigues you the most? Let us know in the comments.